Okay, so here we have this big, scary-looking table of trig identities. There are 24 of them, in fact. These are the correlated angle formulas, and they show us how to add pi over 2, negative pi over 2, 3 pi over 2, or negative 3 pi over 2 to the theta, the argument or input, as we call it, to sine, cos, tan, cotangent, secant, cosecant. And you might be looking at this and wondering, how on earth am I ever going to memorize all of these things? Because maybe someone told you you have to memorize them or some of them. What we're going to see in this video is that you actually don't have to memorize any of them. If we know how to use the unit circle to do trig stuff, then we can get every single one of these really quickly and really easily just by drawing a little picture. So what we're going to do is pick one of them, say, let's take cosine of theta plus pi over 2, and we're going to draw our picture, put it on the unit circle here, and figure out what cos of theta plus pi over 2 is equal to. And not only are we going to get cos of theta plus pi over 2, we're actually going to get this entire column, right? We're going to get 1/4 of these things with one picture. How are we going to do that? Well, we need to know that on the unit circle, if we stop at a point here, if our terminal arm, starting out at theta is equal to 0, rotates counterclockwise by an angle theta, and by the way, we're putting theta in the first quadrant here just because it's the easiest to see, but this works with theta in any quadrant. You can check that. It's actually a very good exercise. But if we rotate by theta and stop at some point here on the circumference of the unit circle, the x-coordinate that we stopped at is the cosine of the angle theta, because cosine of theta is this side divided by 1. So this is our, and it's very useful to put in the x here. I'm going to write x in there. Cos of theta is x over 1, which is just equal to x. So the cosine is the x-coordinate of this point. Same thing, the sine is the y-coordinate, right? It's how far we've gone up to get to that point. And then for any theta which is not in 0 to 90, which is, say, bigger than 90, even bigger than 180, or negative, if we rotate around by that angle, say this is phi on the unit circle, and we stop at a point here, x, y, then this x is cosine of phi, and the y is sine of phi by definition. That's a very quick recap. If you're not familiar with any of this stuff, though, please do check out the videos on the unit circle where we go into a lot of depth in this. Okay, so how are we going to use this to find cosine of theta plus pi over 2? Well, we're going to remember that theta plus pi over 2 is the same as pi over 2 plus theta. So cosine of theta plus pi over 2 is the same as cosine of pi over 2 plus theta, and we can take our terminal arm and rotate it by pi over 2 counterclockwise. That gets us up to here, right? That gets us pointing directly north on the unit circle, and then by another theta. So we're going to rotate it by another theta after that. So this will be theta here, theta rotated away from the y-axis, the positive y-axis here, and we are going to get this triangle, orange on that side and blue on that side, and this is the key to the whole thing, and also we will have a right angle here. This is the key to the whole thing because by rotating theta away, theta out from the positive y-axis, we get the same distance. We get the same distance from the y-axis here, this orange distance, that we got from the x-axis here by rotating theta in this direction. The same angle takes us the same distance away from the axis that we're rotating away from. So this y here, or this, that kind of blown the secret, that orange side here is the same as the y here, right? These are the same distances. Also, this distance here, this vertical distance, is the same as that x distance, right? It's the same as the horizontal distance we went over here. Why? We can solve for that side using the Pythagorean theorem, because this is the unit circle, right? This is a triangle with a hypotenuse of 1 here. This is a hypotenuse of 1 here as well. And now we're basically done. That's literally it, right? The coordinates of this point here are cosine of pi over 2 plus theta and sine of pi over 2 plus theta. By the definition of the extended sine and cos functions, the sine and cos functions that are defined for all real numbers, not just numbers which are in between 0 and 180, right? The y-coordinate of this point is sine of pi over 2 plus theta, and the x-coordinate is cosine of pi over 2 plus theta. But what are these coordinates? What is the x-coordinate of this? And of course, cos of pi over 2 plus theta is the same thing as cosine of theta plus pi over 2. So what's the x-coordinate at this point? Well, from the y-axis, we went to the left by this distance y, the same distance y that we went up from here. So the x-coordinate is actually going to be negative y, right, going to the left by this positive y distance. What about the sine, the y-coordinate at this point? Well, we went to the right by x here. Here we went up by x. So this horizontal x is how much we went up to get to this point there. We went up by x, left by y. So this is going to be x. But what are x and y? Well, let's go back over here to our original point that we were looking at. X and y are cosine of theta and sine of theta. So what is this showing us? This is showing us that cosine of theta plus pi over 2 is negative sine of theta, right? It is negative y, where y was sine of theta. Also, sine of theta plus pi over 2 is equal to cos of theta, right? It's the x where x was equal to cosine of theta, right? That's what sine of theta plus pi over 2 is. So we didn't just get cos of theta plus pi over 2 is negative sine of theta, and we can go back and check these, right, from our table in case you don't believe me about this, but hopefully we can believe it because we see it right in front of our eyes. That's the great thing about the unit circle. You can literally see why things are true. No memorization required. We also got sine of theta plus pi over 2. What about the rest of them, though? What about these other four? You might be thinking, well, these are defined in terms of sine and cos, so of course we get these for free, right? Tan of theta plus pi over 2 is sine of theta plus pi over 2 divided by cosine of theta plus pi over 2. We just saw that sine of theta plus pi over 2 is cos of theta, and cos of theta plus pi over 2 is negative sine of theta. So this ends up being negative cosine of theta over sine of theta, which is negative cotangent of theta. So we get the tan of theta correlated angle formula as well. What about secant of theta plus pi over 2? Secant of theta plus pi over 2, well, that's 1 over cos of theta plus pi over 2, which is 1 over negative sine of theta. So this is negative cosecant of theta. We get that one. What about cosecant of theta plus pi over 2? Cosecant of theta plus pi over 2. This is 1 over sine of theta plus pi over 2, which is 1 over cosine of theta, we already showed, which is secant of theta. And then what's the last one? Cotangent of theta plus pi over 2 is cosine of theta plus pi over 2 over sine of theta plus pi over 2, which is negative sine of theta over cosine of theta, which is negative tan of theta. So we get all 6 of these, again, just from this one picture. So basically, all we really need to look at is this part of it, the plus pi over 2. We're doing the plus pi over 2 column of the table, right? If we want to know any of these, and we're going to do the other 3 in the next 3 videos, all we have to do is look at, is it adding pi over 2, subtracting pi over 2, adding 3 pi over 2, or subtracting 3 pi over 2, and then we draw one picture, one little picture here, we get the entire column, and we can figure out what is sine, cos, tan, cotangent, secant, cosecant of any of these. And I really want to emphasize, now that we've seen how easy this is to get all of these things with one picture where we understand actually what the extended sine and cos and tan are using the unit circle, this is the definition of these things. If we have that little bit of understanding, we can get all of these things. So in the next videos, we're going to see how to do negative pi over 2, positive 3 pi over 2, and negative 3 pi over 2.